detected. So 100% recall. So recall and precision are very popular in information retrieval. So think about the Google. Do you think the Google is perfect to retrieve the data? But when you search the certain information, how many times retype, or the scroll down and the next page? Actually, Google return as much as possible and rank it. And if you consider the top 5 as a real true, how many of them are correct? They have the actually low precision and very high recall. That's the reason Google can be very popular. That works in the non-critical system like the Google. Even though Google failed, nobody cares. You can retrieve it again and again and just complain. What about the cancer, medical diagnosis? At that time, recall should be high, even though we lose some precision. Does it make sense? The recall means we don't want to lose real Ebola case, positive case. Even though many of them are not precise, he's not positive, not positive, but I don't want to lose real positive case. In terms of precision, TP plus FP will be very high, so which means it's low, but in terms of recall, true positive and false negative still correctly detect. So precision and recall can be used for the evaluation metric also. By combining precision and recall is harmony means, that is the F measure. Okay, so F measure is also used. So this is the example of the precision and recall. Precision and recall is how the 90. The precision, how much precise from the out of the return 200 among the 230. The cancer positive case 90 will be corrected. So 40 precision, and recall is actually the among the 300 the positive case 90 is returned, so 30%. So still very low the recall. So recall should be increased to be used for the medical application. So another accuracy measure is to measure such a test it. Sometimes when we have the smaller test data or the training data set, it's very hard to believe how the reliability of the algorithm or classifier. So at that time, so hold out method means, so we are going to test. So we have the 100, the data set, 100 data in the data set. So we can use some portion of the data as the training, so 2/3 and 1/3 for the test. Okay, prediction. And run it and get the accuracy in terms of recall or precision or the specificity or the sensitivity, whatever. Then mix up and randomly select 2/3 of the data as the training and the other testing and evaluate. Maybe slightly different and or the huge different, and run it again. How many times? For example, 10 times, k number of times, and average. That is hold out method. You can test to make sure whether my algorithm has consistency. Okay? Reliability. You learn and mix up. You learn, mix up. You learn, mix up, number of time and average. That is hold out. Cross validation means the 10-fold is the most popular. 10-fold means, so I have the 100 data set divided by 10. Okay, one of them used for the testing. This one for the training based on test. Training based on test. Training based on test. 10-fold. We can make the 10 segmentation, then apply one of them as the they should be mutually exclusive. Okay? The holdout is actually mixed up. Each data set are related. Okay, biased. However, 10-fold is a mutually exclusive divide. So one of them use one of them, and so on. Okay, that is the cross validation. Stratified cross validation is most popular one. That means when we divide the data, it tries to make the as same distribution as possible of the original data, which is not easy. But try to make. For example, the overall entire data set has average 5. But this one has average 7, this one is average 3, it's a 6, not 5, but average is a 5. So it cannot actually represent the testing with the entire data set or the general case. So try to make the as same as possible for each layer. So stratify means the layer. Okay, so we can try to make, which is not easy, but because of the high computational power of the computer, we can nowadays can make this one. You can think about how. Bootstrap is an interesting approach to for the evaluation the method. Sometimes it's called the 0.632 bootstrap. Okay. The bootstrap means why don't we read? So we have the D data. Okay. Then first we select one of the data and test it. Okay. Then next, the data tuple did not make it into the training set and end up forming the test set. The next time, we will select one of the data. We put it back to the data set. It's a replacement. Then pick up another one. So the probability is 1 minus 1 over D. How many times? D time. That will close to the natural, the exponent E. Okay, minus 1. So that is actually 0.6368. Close to the 368. So positive case, it will be 632. I didn't prove it. It's the textbook said. So this one is called the bootstrap. So bootstrap is running again, but the data set used for the test. So hold on. Samples given training tuple. Tuple is this selected and we added training. Okay, this will go back to. This is based on the replacements. Going back to the training data set and pick up the one of them again. That probability will be the positive case is the 368 is never chance to be picked up. So 36% of the data is never been the pickup, and 63% of the data will be at least one time picked for the testing data set. Okay, that is the reason it's called the 632. Okay, so this is the bootstrap approach. Usually it's used for in case you have the very small data set. Okay. I'm going to skip this part. ROC curve is used a lot for the signal processing. When we send the signal, okay, how much of them are correctly received, something like that. So this is ROC curve, but this one is used for sometimes the information retrieval system, but not much in the data mining. Okay. So we already see some of the issues when we select such a model, how much accurate, the higher accurate is the better, but not always the accuracy. We need to think about the speed. Okay, when we do, usually the classifier, the decision tree require very high computation. Okay, and the robustness is whenever you learn the classifier, it provides the same the accuracy level. Okay, and scalability, widely we have the more data, and interpretability, we have the very nice decision tree. It's easy to understand. Even though we have something for example, navigation, which is not understood, so we cannot use that. Okay. Then, is there any way to improve the accuracy of such a classifier? The classification algorithm. there are different ways. The most popular one is ensemble approach. Before that, bagging is I think that this one analogy is a better way to understand the bagging algorithm. So, for example, when you are sick, so you can go to the doctor 1, doctor 2, doctor 3. So diagnosis is based on the multiple doctor, and he said you are positive, and negative, positive. So I'm positive for the allergy. Okay, so I decide. So that is the bagging approach. So bag is put the all the thing, and the majority will be selected. It's the same thing for the classifier. So we can run this way, this way, this way, and decide that this new data belongs to yes, because 3 out of 4 select the yes. That is a bagging approach. And boosting is we are going to make the kind of average. So 75% yes, 25% no. 70%, 5% I'm the allergy. Positive, 25%. So it can be used for some continuous data. Okay, so as a probability. Okay, that is a boosting algorithm. Okay, then last one is an ensemble approach, which is the most popular one. Where is the ensemble approach? Right here. The ensemble method is you can combine the learning the next to each other, M1, M2, M3. Okay, so combining. So different classifier. Okay, so this one, the bagging and boosting, is a different setting for the same classifier, but also you can consider the different classifier to boost up. Mostly such a ensemble approach provides better accuracy. So when you are doing your research, also you can consider the ensemble approach. If you can get you have your expectation when you learn. So when you implement the classifier, then if your classifier cannot reach your expectation, think about the ensemble approach also. Okay, that is to way to increase the accuracy. Okay, so that's pretty much done. Next week, so I'm going to